Hi students, good morning. Last class we discussed about the molar fraction, mass percentage, volume percentage, mass by volume percentage, parts per million, and molarity. So in that molarity, still some concept is there. That is volume and molarity relationship. So whenever to dilute the solution from one concentration to another concentration, we have to use the equation v2 minus v1 is equal to m1 minus m2 into volume by 100. Otherwise, we may also use this equation higher concentration minus lower concentration by lower concentration into volume of the solution. And this is the equation we have to use to calculate the volume of water required to dilute the solution from m1 concentration to m2 concentration. For example, so we have the 1 molarity of NaOH solution. This we have to convert into 0.5 sorry 1 molarity of NaOH we have to convert into 0.5 molarity of NaOH solution. So to convert this one we have to add the water. So how much amount of water we have to add to convert the 1 molarity of NaOH into 0.5 molarity of NaOH? At the time we have to use this equation. Here 1 molarity and 0.5 molarity is there. Higher concentration is 1 and lower concentration is the 0.5 by lower concentration is the 0.5 into volume. So for how much amount we have to increase the solution means, for example, 1 liter. So means based on this equation we can easily find out the volume of water required to dilute the solution. And one more is and to calculate the resultant molarity of the solution by mixing the two solutions. For example, here I have the one test tube. So in this test tube, if I take 1 molarity of HCl and the volume of the solution is the 500 ml, and again in another test tube I took the 2 molarity of NaOH and volume of this one is the 500 ml. So if I mix these two solutions, for example, here is there in another test tube, I am adding that 1 molarity of 500 ml of HCl and 2 molarity of 500 ml of NaOH solution. This is the solution is having the different volume and molarity different molarity. So to find out the resultant molarity of the solution we have to use the equation m is equal to m1 v1 plus m2 v2 by v1 plus v2. So here resultant molarity m is equal to m1 is how much 1 and v1 is 500 ml plus m2 is 2 into 500 by 500 plus 500, then we can get so 500 plus 1000 by 1000, then here we can get the 500. Okay, and like this we can calculate the resultant molarity of the solution. So for the titration we can use the equation m is equal to m1 v1 minus m2 v2 by v1 plus v2. Okay, next one, if any solution is having the molarity is the 1, such solutions are called as the molar solutions. If solution having the 0.5, semi, zero point 0.1 is the decimolar, and 0.01 is the centimolar, 0.001 molarity. Such solutions are called as the millimolar solutions, and these are the terms are very useful for the calculations. And next one is the normality is there. Okay. Next one is the normality. So here normality we represent with the letter capital N. So normality means number of gram equivalents of solute present in 1 liter of solution is known as the normality. And just by seeing this equation we can easily write the normality definition. Here normality N is equal equivalent weight of the solute present in 1 liter of solution is known as the normality. And from this equation only we can write the units. And here gram equivalents weight per liter are the units for the normality. And as a molarity, the normality is also depends on the temperature. As the temperature is increases, the normality is decreases, because so here normality N is equivalent weight by volume is there. So temperature is increases, the volume of solution is increases. When volume of solution is increases, normality is decreases. Means the relationship between the volume and the normality is inversely proportional. The volume and temperature is directly proportional, so that as temperature is increases, the normality is decreases. And we know that to find out the number of moles, N is called weight by gram molecular weight for the molarity. But for the normality, number of moles is equal to weight by gram equivalent weight. So gram equivalent weight for the normality, gram molecular weight for the molarity. And here normality N is equal to number of gram equivalent weights of the solute, means weight by gram equivalent weight into 1 by volume in liters. And if you take the volume in a ml, the normality N is equal to weight by gram molecular weight into 1000 by volume in ml. And in the similar way for molarity, we discuss the number of formulas. Just N is equal to 10 into X by gram equivalent weight. And normality N is equal to 10 into X into D by gram equivalent weight. And even normality N is equal to 10 into specific gravity into X by gram equivalent weight. So in a molarity we can use the gram molecular weight, in a normality we can use the gram equivalent weight. And here we know that here X is equal to weight by volume percentage, and the specific gravity, here also X is equal to what, here X is equal to weight by volume percentage. You have to remember this X value. And next one, the relationship between the molarity and normality. So this is very important. Normality is equal to molarity into N, and here N is equal to acidity of the base, basicity of the acid, or total number of positive charges or total number of negative charges, or change in a number of electrons in the redox reactions. For example, you can take a H2SO4. When this H2SO4 can undergo dissociation, we can get the 2H plus SO4 2 minus. Means for example, normality N is equal to, molarity is the M, and here N is equal to maybe acidity, basicity, or total number of positive or negative ions. Now here this is the acid. For the acids we have to use the word basicity. So the basicity for this acid is the 2. For example, 0.5 molarity of H2SO4 contains how much normality? The normality N is equal to 0.5 molarity into uh, basicity of this acid is the 2, then we can get the normality is equal to 1. And even you can take the calcium chloride CaCl2. When calcium chloride undergo dissociation, we can get the calcium plus 2 plus 2Cl minus. And for this salts, we have to take the total number of positive or total number of negative ions. Any one we have to take. For example, 0.6 molarity of calcium chloride contains how much normality? Means normality N is equal to molarity is the 0.6 into total number of positive charges. This is the total number of positive charge, that is the 2. Then we can get the normality is equal to 1.2. Means like this we can calculate the relationship between the normality and molarity. And even for a oxidizing agent, for reducing agent, we can take the change in number of electrons. KMnO4 is there. In a acidic medium, this KMnO4 is converted into Mn plus 2, and KMnO4 in a basic medium, it is converted into Mn plus 6. Means here change in number of electrons here is the 5, and change in number of electrons here is the 1. Sorry, change in number of electrons is 1. We know that oxidation state of manganese is the plus 7, and here also manganese is the plus 7. So in acidic medium, change in number of electrons is the 5. In basic medium, change in number of electrons for the potassium permanganate is 1. And this is about the normality. And next one is the molality. So molarity different and molality is different. So molality we represent with the small m. So molality means number of moles of solute present in 1 kg of solvent is known as the molality. So molarity is a number of moles of solute present in 1 liter of solution, but molality present in 1 kg of solvent. So molarity M is equal to number of moles by weight of solvent in kgs. And here also units are moles per kg, and it is independent on temperature. Means as the temperature is increases, so mass of the solvent does not changes, so that it is independent on the temperature. And the relationship between the molality and solubility is 10 into solubility by gram molecular weight, and molality is equal to 1000 into x by gram molecular weight. Here x is equal to weight by weight percentage. For the normality, for the molarity we used weight by volume percentage, but for the molality weight by weight percentage. And the relationship between the molality and molarity is, this is the equation. Okay. And very important point is, so molarity, normality, volume percentage or depends on the temperature, and the rest of the methods are independent on the temperature. Because in molarity, normality, in volume percentage, in denominator side volume is there, so that they can depends on the temperature. So rest of are independent on the temperature. Now we will see the problems based on the above concepts. Now we will see the problems so based on the concentration methods. So first problem is 3.65 grams of HCl dissolved in 2 liters of solution. Find the molarity of the solution. So first we have to analyze the question. So in that first we have to write the parameters what they gave. So here weight of HCl is equal to 3.65 grams, and it is dissolved in 2 liters of the solution, means volume of solution is equal to 2000 ml you can take. Then here what we have to find out? Molarity we have to find out, that is the question mark. And then here the compound they mention, gram molecular weight of HCl is equal, so hydrogen is the one and chlorine is the 35.5, then we can get the 36.5. Gram molecular weight is 36.5. Now we know the weight, gram molecular weight, volume. Then we have to find out the molarity. So molarity equation is, what is the equation? M is equal to weight by gram molecular weight into 1000 by volume of the solution in ml. Then weight is equal to what? 3.65 by gram molecular weight is the 36.5 into 1000 by 1000. Then here we can get the 1 by 2. Then here we can get the, if you simplify this one you will get the answer. Okay, and the we will get the answer is 0.2 molarity. Okay, so the next question is 10.6 grams of sodium carbonate are dissolved in water to give 2 molarity of solution. What is the volume of solution in ml? So first write the parameters what they give. First one is weight of Na2CO3, so that is the 10.6 grams. Gram molecular weight of Na2CO3, that is 106 we will get. So if you calculate the, you know how to calculate the molar mass or molecular mass of the compounds. So here gram molecular weight of sodium carbonate is 106, and molarity already they mentioned, the molarity is equal to 2. And here what we have to find out? Volume is the question mark. Now see what is the formula? Molarity M is equal to weight by gram molecular weight into 1000 by volume in ml. So in from this what we have to find out? Volume we have to find out. Volume is equal to, so what we can get? So weight into 1000 by m into gram molecular weight, then volume is equal to, weight is 10.6 into 1000 by molarity is the 2 into gram molecular weight is the 106, then volume we will get a 50 ml. So this is the answer for this question. Okay, so next third problem is calculate the molarity of 4% NaOH solution. Here also what we have to find out? Molarity we have to find out, that is the question mark. Here 4% of NaOH solution. Here 4% means 4 grams of NaOH present in 100 grams of solution, means weight of solute is equal to 4 grams. Gram molecular weight of solute is 40. Here NaOH gram molecular weight is 40. Then here molarity M is equal to weight by gram molecular weight into 1000 by volume in ml. So here they didn't mention the volume, so that molarity M is equal to weight by gram molecular weight only you can take. Weight is equal to 4, and gram molecular weight is the 40 into 1 by this one we can get 1000 by volume in ml. Then here the answer is 1 molarity. Okay, and the next one is, so 10 ml, 100 ml, 0.1 molarity H2SO4 is exactly neutralized by 100 ml of NaOH solution. Calculate the molarity of NaOH solution. So read the question carefully. So volume of H2SO4 is the 100 ml, molarity is the 0.1, and volume of NaOH is the 100 ml. We have to find out the molarity of NaOH, and this one is the neutralized reaction. For example, H2SO4 is reacting with the NaOH, then we can get Na2SO4 plus H2O. We have to balance this equation here too. Then now the equation is balanced. Here number of moles of H2SO4, if it is the N1 is equal to 1. Number of moles of NaOH here, how many moles are there? 2 moles are there. And the volume of V1 H2SO4 is the 100, and V2 is also 100, and M1 is what? 0.1 molarity, and M2 is the question mark. Now we know these parameters. From this one, what is the equation we will get? So the equation is M1 V1 by N1 is equal M2 V2 by N2. So from this, what we have to find out? M2 is equal M1 V1 by N1 into N2 by V2. Now substitute the values. So M1 is the 0.1 and V1 is 100 into, and N2 is 2 upon N1 is 1 and V2 is 100. Then if you simplify this one, you will get the answer is 0.2 molarity. So this is the answer. And next one is if you see the fifth problem, and fifth problem is how much water must be added to 2 liters of decimolar NaOH to get a centimolar NaOH solution. So in molarity I said, if solution is having the 1 molarity, that is the molar solution. 0.5 is the semimolar solution. 0.1 is there, means decimolar. 0.01 means centimolar solution. Means here amount of water is required to dilute the solution. Decimolar means what? Decimolar solution means 0.1 molarity. So this one you can take the higher concentration. Next one is the centimolar. Centimolar is the 0.01 molarity. Then volume of solution is what? Volume of solution is the 2 liters, that you can take the 2000 ml. Then what is the equation? So to find out the volume of water, required is equal higher concentration minus lower concentration upon lower concentration into volume. So here higher concentration is what? Decimolar is the higher concentration, means 0.1 minus 0.01 upon 0.01 into 2000 ml. Then if you simplify this we will get the answer is, so we will get the answer is 0.9 into 2000, then 1800 ml. Means this much amount of water is required to dilute the solution from zero point 0.1 concentration to 0.01 concentration. Okay, and next one is a calculate the molarity of a mixed solution by adding 150 ml of 0.1 molarity HCl to 200 ml of 0.1 molarity of HCl solution. Means resultant molarity we have to find out. For the resultant molarity, M is equal M1V1 plus M2V2 by V1 plus V2. And here M1, for example, if you take the HCl, M1 is the 0.1 and V1 is the 150 ml, and M2 is the 0.2 and V2 is a 200 ml. Substitute these values in this equation, then here we can get M1 is 0.1 into V1 is 150 ml plus 0.2 into 200 by, so 150 plus 200, then we can get the 350. And if you simplify this, if we get here 15 and plus here 40 by 350, then here we can get the 55 by 350, and if you simplify this one, we will get a 0.15 molarity. Okay, means the resultant solution, means after mixing these two solutions, the resultant solution having a molarity 0.15 molarity. Okay. And the next seventh one is calculate the normality of H2SO4 solution containing 4.9 grams per liter of the solution. And here normality we have to find out. Normality and is the question mark, and weight is 4.9, and normality equation is normality n is equal to weight by gram equivalent weight into 1000 by volume in ml, volume in ml. And here weight we know, then gram equivalent weight is gram equivalent weight. To find out the gram equivalent weight, we have the one equation, that is the weight of the compound by valency, weight of the compound by valency. So here H2SO4 gram molecular weight is equal to 98 grams, and valency or basicity of this acid is the 2, then we can get the 49. Then here normality, so weight is equal to 4.9, gram equivalent to weight is the 49, and here 1 liter they mentioned, so that normality n is equal to weight by gram equivalent weight into 1 by volume in liters. Weight is equal to how much? 4.9, and gram molecular weight is the 49, then we can get the answer is 0.1 normality. Okay, this like this we can calculate the normality of the solution. Next one, calculate the molarity, sorry, calculate the molality of 9.8 percentage solution of sulfuric acid. 9.8 percentage of solution of sulfuric acid. So here 9.8 percentage means, so 9.8 percentage means what? 9.8 grams of H2SO4 present in 100 grams of solution. So 9.8 percentage means 9.8 grams of H2SO4 present in 100 grams of solution. Means here weight of solute is equal to 9.8. Weight of solution is equal to 100 grams. Then weight of solvent, so weight of solvent is equal to weight of solution minus weight of solute. Weight of solution is how much? 100 minus 9.8, then we can get the 90.2 is the weight of solvent. Then here what we have to find out? Molality we have to find out. So molality we represent with the small m is equal to weight by gram molecular weight into 1000 by weight of solvent in grams. Weight of solvent in grams. Then here weight is equal to 9.8 by gram molecular weight of sulfuric acid is the 98 into 1000 by weight of solvent in grams is 90.2. And if we simplify this, we will get the answer is 1.108 1.108 molality, and this is the answer. Okay, and next one is calculate the mole fraction of sulfuric acid in a solution containing 98 percentage of sulfuric acid by weight. Here also same, 98 percentage means 98 grams of sulfuric acid present in 2 grams of water. 2 grams of water. So here weight of H2SO4 is 98. Gram molecular weight of H2SO4 is also 98. Next one, weight of water H2O is the 2 grams. Gram molecular weight of H2O is 16 to 18. We can get. So here mole fraction of sulfuric acid we have to find out. What we have to find out? Mole fraction of sulfuric acid. So mole fraction equation is what? Mole, for example, in this one sulfuric acid is the solute and water is the solvent. Then mole fraction x, mole fraction of solute is equal number of moles of solute by number of moles of solute plus number of moles of solvent. And to find out the number of moles of the any compound, number of moles is equal weight by gram molecular weight. So weight of solute is how much here? 98, and gram molecular weight is also 98. Then number of moles is 1. And next one, number of moles of water H2O is equal weight is the 2 grams, gram molecular weight is the 18. Then here the number of moles of H2O we can get 1 by 9. Now substitute these values in this equation. Here number of moles is the 1 by 1 plus 1 by 9 we will get. So if you simplify this one we will get the answer.